Hi everyone. So today we're going to look at basically the use of sine, cosine, and tangent and how we can use it to find missing sides of right triangles when we don't have enough information to be able to use the Pythagorean theorem. So first thing is some calculator information because you're going to have to be able to put these into your calculator. So for what we're going to be doing, we're always going to want to make sure our calculator's in degree mode because we're going to be talking about our angles in degrees. So if we're taking sine of 30 degrees, we need to tell our calculator that 30 is in degrees. So that's always going to be your rule of thumb. If you're taking sine, cosine, or tangent of a degree, like 30 degrees, 50 degrees, you always want to make sure that your calculator is in degree mode. So the first thing is going to be how to change your calculator into degree mode. So if you go to your calculator, just go into like the home screen and then you go to the calculate button. So like basically it should look like the background of this, just as if you were going to do some kind of calculation. What you're going to do first is you're going to press this dock button here. So go ahead and press that and then just type number 7, or you could scroll down and then to number 7 hit enter. It's easier just to hit the number 7. So you should be selecting the setting that says settings and status. And then from there, you want to hit number 2 for document settings. And then once you're in that screen, you should see something that looks like this. And by angle, it'll probably say radian. It might say degree, depending on if your calculator's already been changed or not. But if you go to where the angle spot, you want to hit this arrow down and you want to select or highlight degree. So this will be how you change it to degree mode. Once that's selected, you can arrow down or hover the cursor down to make default. Instead of just saying okay, let's just say make default. That way, hopefully when we turn these back on, they'll stay in degree mode. So you don't always have to go through this process. So hit make default and then just say okay. And then what's going to happen if you are truly in degree mode, if you're in the calculate screen, you should see right in here, it should say degree. So this one is still in radians, this screen. That's why that says rad, I guess it would be pronounced. But it should say degree. So if it still says rad, then you need to go back to the previous page and follow those steps and turn it into degree mode again. If you guys have the old calculators, the black calculators, then you just need to go to mode. So there's a key. So this is for the 83s. Just hit the mode key. And then you just want to change, like you'll see a spot where it's like shaded where it says radian or degree. You just want to make sure that you select degree. And then just hit enter and then hit second quit to get out of that screen. So that's for the 83s or 84s. They all work the same way. So from there, once your calculator's in degree mode, the nice thing about the Inspires, the new calculators, is you'll always be able to see when you're doing a calculation. Your check to see if it's in degree mode is just to look up top. If you have the old calculator, you have to go back to mode and actually look to see which one's highlighted. So just be aware of that. With these, you always want to keep an eye on that. Make sure that that stays degree. It should, since you made it a default, but you never know, someone could change it or something happens. If they get reset, then they go back to radian, so just make sure that you're checking that. So once your calculator's in degree mode, what I want you to do is just practice taking sine of something, because if you remember, yesterday we looked at that table and it had like sine of 27 degrees. You could go to the table and you would look what's the ratio of basically the opposite over the hypotenuse for the angle 27 degrees. That's really what you're finding when you're finding sine of 27 degrees. So the table gave you that. If you don't have a triangle and you don't have any information and you want to know sine of 27 degrees, you're really asking, you can do this in your calculator, and what your calculator is giving you is what's the opposite over the hypotenuse of the acute angle 27 degrees in a right triangle. So if you type in, if you want to be able to do this, you're going to go to the trig button. So the trig button is right under that gold button. So right here it's highlighted. So you click that and you're going to get all of these different options. So for this course, we're not going to use any of these. So don't ever use those. Those are going to be for Algebra 2. So don't worry about those for this class. Um, for this video, we're only going to focus on these top three because those are the only ones we've talked about, sine, cosine, and tangent. These ones with a little -1 we're going to talk about in the next lesson, so don't worry about those for right now. So what I want you to do is just type in something. So go ahead in the calculate screen, hit the trig button, make sure it says degree, and then press sine, and you should see the parentheses. Go ahead and type in some measurement, some angle. I would try 30 first just to make sure that you're getting the same answer. Because if your calculator, see how this says degree, if your calculator doesn't say degree here and it says radian, then that means you're gonna get a different answer. So make sure that that says degree, and then make sure when you type in sine of 30, you get 0.5. If you don't, go back to that previous page because you got to change the mode on your calculator. So what this is saying is sine of 30 degrees equals 0.5. So if we had a right triangle and one of the acute angles was 30 degrees, if we took sine of that, meaning we took the opposite over the hypotenuse, we would get 1/2. So that would be the ratio. It could be 6/12, but that would reduce to 1/2. So that's what this is saying. So you could do that for numerous, try whatever you want with sine, cosine, or tangent, but you're going to get some messy decimals. So just be aware of that. So let's go ahead, once you have that figured out, let's go ahead and go to the next page, and we're going to actually use this. So what's the whole purpose of this? So one of the most well-known purposes of these trig functions is using them to find missing sides of a right triangle. So right now, you know how to find a missing side of a right triangle when you have two sides. So let's say I have some right triangle, and I know that this is 3, and I know that this is 5, and I don't know this side. Well, I could use Pythagorean theorem to figure that out. X squared plus 3 squared equals 5 squared. So we get x squared plus 9 equals 25. And then you subtract, you get x squared equals 16, you get x equals 4. So you can find that right now. Some of you might have just looked at that and said, oh, that's a special Pythagorean triple, 3, 4, 5, and you would have known it. So we already have that. That still applies. You can use Pythagorean theorem to find a missing side. These trig ratios, sine, cosine, tangent, or SOHCAHTOA, or way to remember it, can be used to find missing sides when you don't have enough information to use Pythagorean theorem. So what I mean by that is if you look at this first example, you can't use Pythagorean theorem to find the length of AB, so I'm going to call that x, because I don't have this side. I would have x squared plus maybe y squared equals 26 squared, and there's no way to solve it. So this is the purpose of the trig, the SOHCAHTOA. So this up here is just a refresher. Remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangents opposite over adjacent. But remember, we use the SOHCAHTOA to help us remember that. So if we look at this first example, the first thing I want you to do is think about what angle is labeled, and that's going to be your reference angle, or that's going to be the angle that you base the opposite and adjacent sides off of. So if we're trying to find the length of AB, I mark an X there. Then what I'm going to do is wherever there's an angle measured, we're never going to use the right angle. We always are going to use our acute angles for these. So, never look at that right angle. So look at your two acute angles. So in this case, A and C. We have 38 degrees on A, so I'm going to circle that. That means I'm going to be using that 38 degrees to help me find this missing side. So from there, now I want to label what's the opposite, what's the adjacent, and what's the hypotenuse. So since I have a measurement on angle A, we're going to use that as a reference angle. That tells me that this side here is going to be the opposite, and the X is going to be the adjacent to angle A. And then 26 is across from the right angle or opposite the right angle, so that's always going to be the hypotenuse. So then from there, I have to decide, so if I have SOHCAHTOA, our acronym here, I'm going to always write this out. I have to decide which trig function I should use, which ratio can I use to set up an equation to be able to solve for x. So if you look, I don't have anything on the opposite side. So that tells me I'm not going to use opposite. So it tells me I'm not going to use anything that has an O in it. And I'm going to use the cosine one, the ka, because it has an A and it has an H. So it has the adjacent and it has the hypotenuse. I have something on the adjacent, x, that's what I'm trying to find, and I have the hypotenuse. So that means I'm going to use cosine of angle A equals the adjacent over the hypotenuse. And it's always going to be the trig function of the angle, because remember, you take sine, cosine, or tangent of an angle, and you always set it equal to the ratio of the sides, because sine, cosine, and tangent are just ratios. That's what they mean. They're the ratio based on that acute angle. So if I'm talking about cosine of A, so A is really going to be 38 degrees, so let's go ahead and plug in that. So cosine of 38 is equal to the adjacent, which is x, over the hypotenuse, which is 26. So there's my equation. So cosine of this acute angle is equal to the ratio of the adjacent to the hypotenuse. So now I just have to solve it. So to solve, you notice you have a fraction. So put this side over 1 so that you can cross multiply. So we get 26 times cosine of 38 equals x. So notice I put the 26 in front because this cosine of 38 is basically going to be one number. Think about that trig table you saw. You could go to 38 degrees under cosine and that equaled one number. So cosine of 38 degrees is just a number, and you're going to take that and multiply it by 26. And I don't want to have to worry about rounding too soon, so I just left it like this, and I'm going to enter this whole thing into my calculator just as I see it. Don't worry about the degree symbol. This should really, the parentheses should be really here. Just go ahead and type in, so let me just rewrite this. Just go ahead and type in 26 times cosine 38 degrees. And your calculator will put the 38 in parentheses. You don't need to enter the degrees because remember your calculator's in degree mode. So your calculator knows when you put 38 degrees in with cosine, it's going to take cosine of 38 degrees. So when you do that, you should end up with 20.5 because it says we're going to round to the nearest tenth, so 1 decimal for x. So that tells me that side AB is 20.5. So let's try another one. So in this, we have a right triangle again. We want to find BC, so I'm going to put an X on BC. We're going to round it to the nearest tenth. So again, I'm going to start with identifying the angle. What's my reference angle? Which acute angle am I using? In this case, I'm using angle B because that's the one that has a measurement. So then from there, we're going to identify what's the opposite side. So it's always the side across from that. The adjacent will be the side next to it. And you might be thinking, well, why isn't this the adjacent? But remember, that's the hypotenuse. That's always across from the right angle. So you almost might want to do the hypotenuse first, and then the opposite and the adjacent are the sides that are going to change. So then I'm going to write my acronym, so SOHCAHTOA. And I don't have anything on the hypotenuse, so that means I'm not going to use sine or cosine. I'm going to use tangent because I have an opposite and I have an adjacent. So we're not using the hypotenuse. So we're going to say tan of the angle, angle B, is equal to the opposite over the adjacent. So tan of 65 degrees equals the opposite, which is 12, over the adjacent, which is x. Then you're going to put this over 1 and go ahead and cross multiply. So we have x times tan of 65 equals 12. Remember, tan of 65 is just some messy decimal. So if you want to put it in your calculator and get a decimal, you can, but don't round until the very end. So I would just leave it like this. So I'm going to get x by itself, which means I need to divide by tan of 65. And when you divide that, make sure you just put it in parentheses so that your calculator knows you're dividing 12 by tan of 65. So those cancel and you get x equals, so then you would just enter this into your calculator, make sure you're still in degree mode, and you end up with 5.6 if we round to the nearest tenth. So that means that side BC is going to be 5.6. So let's just do a couple more so you get the hang of it. So next page here we want to find the value of x to the nearest tenth. And again, identify, okay, here's my acute angle, opposite, draw an arrow across, there's my opposite. The adjacent's going to be the 15 because the hypotenuse is opposite that right angle. So then we think SOHCAHTOA, not using the hypotenuse again, so get rid of those. And we're going to be using tangent. So tan of the angle, which is going to be 50. Since there's no letters on here, I'm just going to jump right into plugging in the 50. Equals opposite, so the opposite is x over the adjacent, which is 15. Remember, opposite over adjacent. Look at that acronym to help you remember. Then put this over 1, cross multiply, so we have 15 times tan of 50 equals x. That should all go in parentheses. Enter that into your calculator. 15 times tan of 50 is going to be x equals 17.9. And this one just says find the value of x, so I'm just going to leave it. X equals 17.9. So last one we're going to look at. So for this one we want to find the length of BC. So again, put an x on BC if that's what we're trying to find. Identify your sides based on the angle they give you. So they give you 34, so opposite. Adjacent will be down here because this side is the hypotenuse because it's across from the right angle. So if you think about SOHCAHTOA, so what side aren't we using this time? We're not using the adjacent. There's nothing on the adjacent. So that means anything with an A we cross off. And we're going to be using sine. So it's going to be sine of that angle. So 34 equals the opposite. So x over h, which is the hypotenuse. So then put this over 1, cross multiply. So 18 sine 34 equals x. So again, type that into your calculator. You get x equals 10.1 when you round it to the nearest tenth. So that tells me that BC equals 10.1. So that's it. So just a couple of things to remind you of. You're never going to be using the 90-degree angle. So the 90-degree angle you only use to identify the hypotenuse. So you should never be taking sine or cosine of tangent of the 90 degree. It should always be of the acute angles in order for this to actually work. And remember, the only sides that'll actually ever change are the opposite and the adjacent. And it all depends on what that acute angle is that they're giving you. So the right angle will always give you the hypotenuse, and that'll always stay in the same place, but opposite and adjacent changes. And then once you identify, you labeled the sides, you identify which theorem or which ratio to use, sine, cosine, or tangent, set up your equation, and then solve. Always make sure your calculator's in degree mode when you're entering in degrees.